Hello everybody and welcome back to Operation Logistics, where we are currently in possession of a hex map, and this hex map can be changed if we actually expose that. Let's pull up this script and go ahead and expose that. So let's go ahead and do a public int map width equals 20 and a public int map height equals 20. There we go. And now, instead of just hard coding 20 by 20, we'll pass in our map width and our map height. There we go. And now we can change our width and height if we so desire. We can have it be a big ol' 100 by 100 map. Like so. Excellent. That is a very large map. Fantastic. We're going to need to get ourselves a bit of a strategy camera here relatively soon, but first I want to do a small tweak, and let's do a bit of height adjustment here. Now, the question is, how do we want to do this height? Do we want it to be a bit more regimented and stylized, or do we want it to be a bit more realistic with Perlin noise / randomization, or do we want it to be kind of terraced? Like with Voronoi noise, which is kind of what I'm leaning towards right now. So let's just go ahead and consider doing that. So we're going to leave the map generation the way it is. And then let's go ahead and create a new function, and I'm just going to go ahead and put it into the start here, just so that I don't forget to. I'm going to say create height. Now, we may pass in parameters later, but for right now, we're going to go ahead and create a new function, public void create height. Okay. There's a couple of variables that we're probably going to be needing. So let's go ahead and create ourselves Voronoi variables. And then we're going to say public int number of height seeds. And for right now, we're going to use 10. So we're going to seed this 10 times. And then we're also going to go ahead and say something along the lines of public int... let's see here. Number of height levels. Number of height levels equals, we'll go with 5 for right now. I'm going to comment out this one, but we're going to do public int water level. We'll come back to that later. For now, we will say that that is 2. We'll come back to that. The other things that we need for our Voronoi variables are relatively small. So let's go ahead and in our generate map, we can actually put in our seeds here if we like, but I think I'll keep it in the create height. So int seeds here equals number of height seeds. So we're pulling that from our Voronoi variables up here. And I'm just going to go ahead and put in a quick comment here, create Voronoi height, so that we know a little bit more of what's going on here. So the first thing we need to do, we're going to need to loop through our entire map twice in order to do this. The first time, we're going to need to place our seeds. Now, we can do this in a slightly different way without looping, and I think I'm going to do this. I'm going to go ahead and do that. So while seeds is not less than 0, so actually while seeds is greater than 0, we're going to stay in this loop. So first things first, to make sure we can get out of it, seeds we will de-increment. There we go. Okay, so while we're in this loop, we need to choose ourselves a hex from the map. So let's just go ahead and say something along the lines of int x equals random.range, and we're going to go for the integer version, and this is going to be between 0 and map width. Okay, so I believe the integer version is exclusive, correct, on the Macs? Yes, it is. Okay, that's perfect. So next up, int y equals random.range 0 map height. Wow, I can't type. Map height. Okay, so now we are choosing ourselves a random location. And the next thing I want to do is I want to make sure that this isn't already a Voronoi seed. So the way we're going to do that is just simply check the y position of the transform. So if map x y dot transform dot position dot y is not equal to 0. Actually, no, if it is equal to 0, then we want to do seeds minus minus. Otherwise, we want to just continue looking for a non-seeded position. So let's go ahead and at this point determine what height we set this to, because this will be a seed. And we should also go ahead and create ourselves a list of game objects. Voronoi seeds equals new list of game object. Okay, so we'll have ourselves a list here, and then down here, Voronoi seeds, we'll make sure to add to the list because we found ourselves where we want to put the seed. So we should probably go ahead and add it to this list. So map x y. Okay, so now we just need to determine what height we want to be at. And we also need to determine public int. Actually, this one can be a float, public float, rather than number of height levels, because we have a certain number of height levels, but we need to get ourselves the height per level. And I'm going to go with 0.5 to start with. So what that's going to do is every time we have a height level, it'll go up by this number, not necessarily by this number. So for example, if we're at height level 3, then it would go to 1.5f. So let's go ahead and set that here. So we need to say int height, actually I'm going to call it height level, equals random.range from 0 to max height levels, or number of height levels. There we go. And then I'm going to say map x y dot transform dot position, position equals new vector 3. We're going to have to make a full vector 3 here. And we don't really care about the x positions for right now. And actually, I'm just going to go ahead and do it this way. This is a little bit easier. So I'm going to do vector 3 new position equals map x. Whoa. There we go. Map xy dot transform dot position. This is just a little bit easier of a way to do this, really. And then I'm just going to say new pose dot y equals height level times height per level. There we go. And then we're just going to assign that back to the position. So equals the transform.position equals new position. And then we add that to our list of Voronoi seeds. So theoretically, it is technically possible, but incredibly unlikely, that our while loop here never actually finishes if it just chooses the same thing over and over and over again. But I'm willing to risk it. So let's go ahead and take a look at that. That should just give us some seeds. So let's take a quick look here. And it did indeed. As you can see, it elevated a few tiles. Not very many. Now, one thing I definitely want to do is I want to bring this back down to 20 by 20 for right now. We can bring it back up later. But I want more seeds per tile. There we go. So now you can see we have several seeds at several different levels. Some of them are obviously floating. Some of them just look like they're, you know, a little bit higher. But that's fine. We can also increase our number of seeds to be like the same as our width and height. We can increase our number of height levels very, very easily, like so, to make our terrain rougher. That might actually be pretty good right there for what I'm looking at. I don't hate that. So now the next thing we need to do is go through and assign everything to its nearest neighbor. Its nearest Voronoi neighbor. And then we're going to need to do a little bit of smoothing probably, but that won't be too bad. So the next thing we need to do is we need to loop through the entire map this time. So for int I equals 0 again, I is less than map width, I++. For int j equals 0 again, j is less than map height, j++. Okay, so we're looping through again, and the next thing we need to do is for each and every tile, we need to say if our transform is not equal to 0, so if map I j dot transform dot position dot y is not equal to 0, then this is a seed, and we don't actually need to do anything with this one right now. So what we need to do with that is then just continue. So it'll just continue to the next one in this for loop at that point. No need to do anything at all. If it's not that, however, then we need to find what the nearest neighbor is. So let's go ahead and do a game object nearest equals, and for right now we will just default to Voronoi seeds 0. That'll be our default starting point. And then actually not a game object, then float nearest distance equals mathf dot infinity. Okay, so we now know that our nearest object is the first in the list, but it's infinite distance away. That's what it's going to default to. The next thing that we need to do is we need to do another for loop for int k equals 0. K is less than Voronoi seeds dot count k++. We just need to iterate through the entire list of Voronoi seeds. And what we're going to do is we're going to do a couple of very quick calculations here. So first things first, this is going to be a bit of a bit of an optimization trick because, okay, I'll do it wrong first, and then I'll tell you why it's wrong. Okay, so what we're going to do here is we're going to say, and actually I'm going to get ourselves another game object, and we're going to have that be map ij, just because I don't want to type out map ij every time. So first things first, this is the wrong way to do it. So if object dot, actually, how do I want to do this? Transform dot distance? No, that's not what I want to do at all. If object dot transform dot position minus nearest dot transform dot position, and then we would want to do like dot magnitude. That's a really slow way to do it. The other way that you can do it is vector3 dot distance, like so, and then have it be object dot transform dot position and nearest dot transform dot position. This is the same exact thing. This is also incredibly slow. and then just say something like less than nearest distance. So this will get us the information that we need, but it's incredibly slow. So the other way to do it we'll get to in a moment, but let's just finish up this function here quick. So we now know what our nearest object is, or rather, we now know how close the object we're considering is in comparison to our nearest object. So if it is, in fact, less than nearest distance, then nearest distance equals, and I'm just going to go ahead and move this out of here and say float distance, just so that we don't have to do this really slow calculation multiple times. We'll store that. So if distance is less than nearest distance, let's store that as the nearest distance. And let's say that, actually, what am I talking about? We don't want to be going with nearest. We want to be going with Voronoi seeds K. There we go. Now that's actually checking in the loop. Nearest distance equals distance, and we want to have, at that point, we want to set nearest to be equal to Voronoi seeds K. Okay, so at this point, we now know in a really inefficient manner what is the furthest object, or rather, what is the nearest object to us. So with that information, all we need to do is just say object.transform.position.y, and we're gonna be changing this, but let's go ahead and say vector3, because we need to set up a vector3, and this is just an easier way to do it. So vector3 new pose equals object.transform.position, new pose.y equals nearest.transform.y, and then we set this back to be new pose. And we need this to be transform.position.y. That would help. Okay, so here we have it. This is a slow way to do this. So let's go ahead and run this. It should run relatively quickly because we're only running it once and we're only running it a few times. Yeah. It ran relatively quickly, and you can see it created us these areas. Like so. Where the areas have different heights. It needs some work, to be sure. But first things first, let's go ahead and hop back into here and get rid of this vector3.distance called. So, is there... I don't think there is. Actually, we can just do a square magnitude. Oh, okay. So the easiest way to do that would then be to just subtract these and say dot square magnitude. Okay, so what this does is the same thing as before with the vector3.distance call, except without a really slow square root call. So this will be a much faster way to do this. So let's go ahead and hop back into here. It isn't a huge difference, probably, but there we go. Excellent. So we've got ourselves some floating islands. Now, one thing we can do to make it so that smoothing isn't necessarily required is we can hop back into Blender and we can grab this and move this down so that it's down another, I don't know, 4 units. Like so. And then import that on in. Okay, come on. Go ahead and update. Did it update? I'm not sure. Oh, yeah, it updated. Excellent. So now you can see we technically don't actually need to smooth it because it doesn't get far enough up. It might, theoretically. I don't know. But that's one way to do it, so that we wouldn't have to do any smoothing. And I think that's a decent solution for right now. I'm just going to go ahead and change this so that rather than 10 height levels, it's back down to around 7. And let's also double the size. I'm also doubling the number of height seeds. Okay. Yeah, this is looking pretty decent. So we now have large cliffs, small cliffs, and just these little terraces, like here. I'm liking this. This is looking pretty good. Yeah, I like that a lot. So the next thing that we can start doing is start doing different hex types and things like that. But realistically, I think our next play is almost certainly going to be to start putting in a camera so that we can actually, start playing the game properly from the game view. And that'll almost certainly be our next goal. I have a standard strategy camera script that we're probably just going to recreate. In fact, we can get started on that right now. Let's go ahead and create ourselves a new C# script and call that strategy camera. There we go. And let's pull that open. And I am going to go find, as a reference, my strategy camera that I have as my default, assuming that this spreadsheet gets out of the way. There we go. Okay, so let's hop over into my game projects folder over here on my other monitor, and we'll head into my grand strategy project that I've been working on for way too long, that I've been kind of ignoring for a while. Okay, so we want to go into the camera module, and here it is. Okay, so I have now located it. So first thing that we probably want to do is we probably want to get the camera positioned correctly. So here's our camera. It's currently in a really weird position. I'm going to go ahead and rotate it to be aiming mostly down 70 degrees. And I'm just going to put it at 0, 10, 0 for right now. And let's see where that is in terms of positioning. That's workable. I'll just maybe move it slightly like that. I think that moved it way too much. I'm pretty sure that moved it way too much. Oh yeah, that moved it way too much. Okay, let's position it right about right. Yeah, that's pretty good. 25, 50. I didn't catch the Z-axis. Oh, that's pretty close. Yeah, right about there. Maybe 10, we'll call it. That'll do. Okay, and then let's run that. Excellent. Yeah, that'll do for a start. Okay, so in this strategy camera, there are a couple of things that we're going to need. And we will need a prerequisite for this as well. So let's go ahead and create ourselves another script as well. And let me just move that script over to this monitor. There we go. So let's create ourselves another script here, and I'm going to call that keybind. Because we will need a few keybinds. Now, we are not going to be needing this to be a mono behavior. We are not going to be needing a start or an update function. There are only a couple of things that we're going to be needing here. So I think we can implement this just incredibly quickly. Now, this is not going to support mouse key bindings at this time. But let's go ahead and get ourselves a system.serializable up here so that we can modify it in the editor. And then let's get ourselves a public key code primary and a second one for secondary so we can bind two things. Now we just need three functions. Public bool is key pressed, which I think we can just truncate to pressed. There we go. And this is when the key is initially pressed on that frame, return true. Because this doesn't work if the key has been held. We'll get to that in a moment. So simply if input.getKeyDown primary, there we go, or input.getKeyDown secondary. So if either the primary or the secondary was pressed that frame, return true. Otherwise, return false. And that's it. We do the same thing for the held. Literally the same thing. Except, I'm just going to copy and paste these, except I'm going to change down to simply get key. So we're going to delete down from both of them here. And then I'm going to comment this: when the key is held, return true. Okay, and then finally, public bool released. And we're going to do the same thing here, except instead of get key down, it's get key up on both of these. And then when the key is held, return false. And no, return true. And it's not held when the key is released. There we go. I was copying this up here. I'm going to go ahead and save that. And that's all we need to start working on our strategy camera. However, it is time to put a cut in here, so I'm going to go ahead and do that, and next episode, we will implement our strategy camera. See you all then.